Going on. So this is just a video tour of the source code repository for this demonstration high-level synthesis system that I've written called DHLS. And this is really just an experiment in how to document code, so hopefully this will be interesting. And this is up to date as of the 18th of December 2018. So I've got a really basic README here, and as the header says, it's a basic high-level synthesis system using LLVM. And basically there's a source directory, a test directory, and there's a bunch of example programs in the test directory that are synthesized by the unit tests. And there's build and test instructions, a bunch of info about dependencies. So here's the source file, here's the test file. I've got a git ignore and a Travis script. Travis isn't actually working yet because I haven't got Z3 installed on Travis, but we'll get to that. And then I've got a CMake list, which is pretty boring, basically just setting up dependencies that work on my machine for, setting up LLVM and setting up Z3 and all that. And then there's a bunch of .v files below there, and these .v files are really just handwritten components that I use to test the Verilog generated by the high-level synthesis tool. So here's a bunch of different RAM types that I wrote that are models of RAM that are used in the test benches, and then all the things with underscore TB are test benches. So here's a test bench that tests a generated module, and this module compare greater than doesn't exist if you're looking around in the repo because it's auto-generated in the unit tests. And I really ought to move this stuff, all these .v's, into their own directory and clean up the way that I do unit testing, but that's how I do it for now. So inside the test directory, there's the LL files, which that's just the C files that I'm using as example C programs to synthesize in the tests. Here's the catch.hpp is just the unit testing framework. I wouldn't look in there. It's kind of boring. And then scheduling.cpp is the test file, and it's pretty big, and it's where I keep all of my unit tests. So as you can see, it's pretty large, and there's a lot of just kind of random crap that I've put in there because this is pretty rapidly developing. So the general format of all the tests, here's the very first test, and this is just the catch notation for tests, test underscore case. And the general notation is basically I load the function that I want to synthesize. So for example, here I'm synthesizing a function called single store. And I basically retrieve the LLVM function and then basically synthesize the code and then run a test bench. And you can look through the test benches to get an idea of the flow. And this load module single store function actually loads the file singlestore.c. So what it really does is calls Clang on this tiny C program and then has Clang output LLVM bitcode, and then loads the bitcode and puts it through the synthesis tool. So the actual HLS code is in source, and it breaks down. Again, these files are pretty big. So there's algorithm.h, which is just a bunch of helper functions that I use in every project that I do in C++. Then there's a bunch of stuff for LLVM code gen. So some of the functions that I use in the unit tests are written in C and then compiled down to LLVM with Clang, and others I just create directly in LLVM, and these are helper functions to help out with that. And CPP is pretty boring there. So then there's also a utils file, which is just utilities for text generation. And then the scheduler is where the actual it's where the actual HLS scheduler is, and includes a bunch of stuff about specifying memories, and here's the different operation types currently supported by the HLS tool. Here's a class that stores different kind of constraints on the scheduler, like how long operations take and how many operations you have. Here's the actual schedule class, and the schedule is basically just a bunch of numbers that describe when different LLVM instructions and basic blocks in the function complete. And then there's a bunch of stuff about expressing the finite state machine that the schedule gets sort of elaborated into. So, here's the state transitions in the finite state machine, the class for that. Here's an explicit representation of a pipeline. Here's the state transition graph, which is the actual class that represents the finite state machine for the generated hardware that comes out of the scheduler. And and so, I usually refer to the state transition graph as an STG. And the critical functions in the scheduler are basically, that you'll see used in the unit tests, are schedule function, which takes in an LLVM function and some hardware constraints and produces a schedule, and build STG, which takes the function that you scheduled and the schedule for the function and converts it into an explicit finite state machine. Then utils is kind of boring. It's just a bunch of stuff for like comma separated lists and text generation. And then there's this Verilog backend.h, and this is, as the name suggests, the Verilog backend. So I've got a bunch of, this is really developing, and I've got a bunch of janky kind of ways of representing Verilog components like wires and memories and always blocks and module instances and stuff like that. I've got a representation of a pipeline that's more elaborate than the pipeline representation in the scheduler, because this system can do some primitive pipelining. And then here's a bunch of options about the architecture, like what the memory interface is and whether there's a global stall. Here's the microarchitecture class, which I'm trying to organize this more, but it's basically just kind of just a sort of catch-all place to store details about the generated Verilog, like which functional units instructions are done on, how the basic blocks are numbered, because you have to track basic blocks in the generated finite state machine, stuff like that. And then there's also just a bunch of stuff like this test bench spec, which is basically just a utility that I created to make it easier to automatically generate Verilog test benches that check the behavior of the generated Verilog. And, here's some code. This is all basically code for debugging, like adding asserts. So you can actually inject arbitrary Verilog into the generated Verilog to do debugging. And then here's a bunch of stuff. These are like a zillion different functions, build microarchitecture that create the microarchitecture from your state transition graph and your function, and a description of basically what kinds of RAM pointers point to, basically, or where in RAMs pointers point to. There's a zillion variants of that, but they're all pretty much the same. Here's a bunch more debug functions. And then the critical function you'll usually, that sort of ties it all together, is emit Verilog. So basically, the general flow in this whole system is you create an LLVM function, you create some hardware constraints, you schedule that, you convert the schedule into a state transition graph, you convert the state transition graph into a microarchitecture using a function like this, and then you convert the microarchitecture into Verilog, and that's pretty much the flow. And that's basically the entire tool right now. You can look through the other files, like the CBPs are just kind of elaborating on that, and it's pretty messy. There's a lot of text generation, but there really shouldn't be, and I'm slowly cleaning things up. But yeah, hopefully you find this walkthrough helpful and gives you some intuition about the repo structure. So please take a look at this repository and give it a star if you like it.